Hello everybody. So what I wanted to do in this video is to prove to you the 0 over 0 form of L'Hopital's rule. Now, we talked about how to use L'Hopital's rule, but we haven't done a proof of it. So we're going to do the proof of the 0 over 0 form. The infinity over infinity form is a little more complicated, a little beyond the scope of this class. So this is what we're going to focus on. So the first thing I want you to notice is that when I take the limit as x approaches a of f of x over g of x, I do a direct substitution, right? And if I get 0 over 0, that basically means that the limit as x approaches a of f of x gave me 0, and the limit as x approaches a of g of x gave me 0. Let me change colors on that. All right, so what I'm going to do is draw a picture that illustrates this point. So here's my point, x equals a. I'm going to draw a graph of f of x equals 0, and its limit as we get close to a is 0. And then the graph of g of x. Let me label those. This is g of x. This is f of x. Now, one of the hypotheses of L'Hopital's rule is that f and g have to be differentiable, which means at that point where x is equal to a, there actually has to be a point on the graph at that point. Because remember, it's not continuous, it's not differentiable. All right, so we have these two graphs. So what we're going to do here is we're going to take these two graphs and involve the idea of local linearity. And remember, local linearity is basically when you use a tangent line to represent a function. So here I go. I'm going to start with f of x. So if I draw a tangent line to x equals a, I need a point and a slope to write the equation of that line. So my point is going to be a, comma, 0. And my slope I find by taking the derivative of f, which is f prime, and plugging in a. So if I wrote the equation of that tangent line, it will be y minus 0 equals f prime of a times x minus a. I'm going to do the same thing for g of x. So I have a tangent line. I want to write the equation of the tangent line. So my point is a comma 0, and my slope is the derivative of g with a plugged in. So my tangent line is y minus 0 equals g prime of a times x minus a. Now, what I'm going to do now is come back over here to my limit, and because these two functions are differentiable, they act like their tangent line really close to x equals a. So I'm going to replace f of x with its tangent line and g of x with its tangent line. So that's going to look like this. There's the tangent line for f. Here's the tangent line for g. Now, if you look at these two tangent lines, you can immediately see that we have a factor on top and bottom that cancels. So that leaves me with the limit as x approaches a of f prime of a over g prime of a, which is basically the limit that you would get if you were taking the limit of f prime of x and g prime of x. The first thing you would do is substitute in a. So those two things are equivalent to each other, and this then is the proof of L'Hopital's rule.